So let's start the discussion. So the first question is, for the given T network, the total series arm impedance is 20 plus J 24 ohm and the total shunt arm impedance is 40 minus J 46 ohm. Then the value of ZA and ZB is equal to dash ohm. Okay. So we are given, okay, this is the network. So the total series arm impedance is 20 plus J 24. So what about each of these arm impedance? It will be half of that. Okay. So this will be ZA is equal to 10 plus J 12 ohm and ZB will be equal to 10 plus J 12 ohm. Okay. So that's the answer for this question. It's an easy answer. Okay. Okay, the next question. Again, the total shunt arm impedance is given as, for the same figure, the total shunt arm impedance is given as 40 minus J 46 ohm. Then the value of ZC is equal to, okay. So we have only one, the network is a T network which is given. So the total shunt arm impedance should be equal to 40 minus J 46 because there is only one element here. So ZC should be equal to ZC should be equal to 40 minus J 46 ohm. Okay. So the correct answer is this one, 40 minus J 46 ohm. Next question. Okay, we are given the pi network. So we are given this pi network. So for the given pi network, the total series arm impedance is 30 minus J 24 ohm and the total shunt arm impedance is 50 minus J 56 ohm. Then the value of ZA is equal to, okay, so ZA is the series arm impedance. So we have only one element, so what should be equal to, what should be the value of ZA? It should be equal to 30 plus J 34 ohm. Okay. So the correct answer is this one, 30 plus J 34 ohm. Again simple one. So for the same pi network, we are asked what is ZB and ZC. Okay, the shunt arm impedances. So the total shunt arm impedance is given as 50 minus J 56 ohm. Okay, so we are having the elements in parallel. So we need the total shunt arm impedance to be equal to 50 minus J 56 ohm. Okay, so what should be the impedance of each of these shunt arms, that is ZB and ZC? So it should be equal to twice of this one. Okay, so that we will have, so it is twice of 50 minus J 56, it will be 100 minus J 112, right? Okay, so when two of such elements come in parallel, we will have 100 minus J 112, so it will be 50 minus J 56. So the correct answer is ZB should be equal to 100 minus J 112 ohm and ZC should also be equal to 100 minus J 112 ohm. Okay, so that is the correct answer. Okay, the next question is, we are given a T network and we are asked the characteristic impedance of the above T network in ohms. Okay, so we have the series arm impedances J25 and the shunt arm impedance is minus J25. So what are these? This is our Z1 by 2, this is our z1 by 2. So what is z1? So it is twice of j25. Okay, 2 into j25 is equal to j50 ohm, and z2 is minus j25 ohm. Okay, z2 is given here. Now what is the expression for our characteristic impedance? Z0 t is equal to square root of z1 z2 into 1 plus z1 by 4 z2, right? So that should be equal to the square root of z1 is j50 minus 25i into 1 plus four times minus 25. So that is equal to 25 ohm. Okay, so the correct answer is this one, 25 ohm. Okay, the next question says that, okay, the same T network is given, and for the above network, if P is the propagation constant, then what is the value of sin HP? Okay, so we have derived the expression, that is sin h gamma or P is equal to Z0 t by Z2. Okay, so in our previous example we have derived, we have found out the value for the characteristic impedance Z0 t, that is 25 ohm. So we will use that result directly here. So it is 25 divided by, and Z2 is minus j25. Okay, so this is our Z2. So that will be equal to, so minus j coming to the numerator will be j, and 25 will get cancelled. So we have j1 as the correct answer. So this is the correct answer. Next question is, for the given lattice network, the characteristic impedance is asked. Okay, so we know that for a lattice network, the characteristic impedance is Z0 is equal to square root of ZA into ZB, where ZA is the series arm impedance, so this is ZA, and ZB is the diagonal arm impedance, so this is ZB. So this will be equal to square root of 44 into 11, so that will be equal to 22. So that's the correct answer. Okay, now the 10th question is, for the same lattice network, what is cottage p by 2? That is, if p is the propagation constant, it is cottage p by 2. So we have derived the relationship that tan h gamma by 2 or p by 2 is equal to root of ZA by ZB. What is cot h? It is actually 1 by tan h, right? So that is equal to root of zb by za. So that is equal to root of, what is zb? So this is za. Zb is equal to 11. So 11 by 44. So that will be equal to that is equal to 0.5. Okay. So that's the correct answer for this. Okay, so the next question is, for a T network, the total series sum impedance is 10 plus j 12 ohm and the total shunt arm impedance is 5 minus j 6 ohm. If P is the propagation constant for this network, then the value of cos h P is. Okay, so we are given the total series sum impedance. So this is equal to Z1. Okay, so Z1 is equal to 10 plus j 12 ohm and the total shunt arm impedance is given as, this Z2 is given as 5 minus j6 ohm, and we are asked what is cos h gamma. Okay, so we have written, so we have derived that cos h gamma, that is P is equal to 1 plus Z1 by twice Z2. So it is 1 plus Z1 is 10 plus J12 upon twice of 5 minus J6. Okay, so that will be equal to, so 1 plus 10 plus 12i divided by twice 5 minus 6i. So that is, on simplifying, it will be 0.8197 plus j 0.9836. Okay, next question is, a T network and pi network has total series sum impedance of 6 plus j8 and total shunt arm impedance of 4 minus j6. If the characteristic impedance of the T network is Z0 T, then the characteristic impedance of the pi network is. Okay, so we have a T network as well as a pi network. Both are having the total series sum impedance Z1 is equal to 6 plus j8 ohm. Also the total shunt arm impedance also is given as 4 minus j6 ohm. Okay, so we have to assume that the characteristic impedance of the T network is Z0 T. Okay, and we have to determine the pi network, the characteristic impedance of the pi network. Okay, so we have to express it in terms of the Z0 T, that is the characteristic impedance of the T network. So we have derived a relationship that Z0 T into Z0 pi is equal to Z1 into Z2. Okay, from here we can write Z0 pi as equal to Z1 Z2 divided by Z0 T. So Z1 is 6 plus j8 and Z2 is 4 minus j6. Okay, divided by Z0 T. So that will be equal to, So we have 6 plus 8i into 4 minus 6i. So that is 72 minus 4i. Okay. So it is 72 minus J4 divided by Z0t. Okay.